Alright guys, this is our review guide that we did, or our practice problems that we did for review on Thursday, November 8th? I'm bad with dates. November 8th, 2018. In part A, the exemplar that I showed you had two fractions, here and here. We're going to get rid of those. Notice how the denominators are both 2. Multiply everything in the equation by 2. So 2 times this first term includes all of this 1/2 times x minus 4. Since 2 and 1/2 are reciprocals, that just leaves x minus 4 plus 2 times 2 equals 2 times 26, which is 52. And over here, 2 times 3/2, the 2 times 1/2 that we did over on the left is the same. The 2's cancel out. 2 divided by 2 is 1, times 3 is 3, so it's minus 3x. We just got rid of all those fractions. Now, we need to combine like terms. We have some constants, numbers, right here that we can use to simplify. So minus 4 plus 4 is 0. And when you have 0, you don't have to show it. It's just x. Bring down the rest, 52 minus 3x. Add 3x to both sides. And you have 4x equals 52. Divide both sides by 4, and you get x is equal to 13. So solving an equation requires steps of simplify, and sometimes you simplify once, sometimes you simplify twice or 3 times. Then eliminate the variable from the right side. If we had a constant, we would eliminate it from the left side, but ours went to 0. We didn't have one. And then we divide by the coefficient. Use your notes to help you as you do these so that you know that you're getting it all, finished. I'm going to move this out of the way for the video. You have to keep it on your paper, but these little markers. So let's start with our problems. Number 1, 6x minus 5 divided by 2 equals 2x plus 6. Every time you see a fraction, you should try to get rid of it. So you should think to yourself, multiply by 2. Multiply everything in the equation by 2. When you multiply the fraction on the left by 2, 2 times the reciprocal 1/2, which is what divided by 2 is, leaves 6x minus 5 equals, and then 2 times each of the terms on the right. 2 times 2x is 4x, and 2 times 6, don't forget, both terms, is 12. Now, eliminate the variable from the right side, because 4 minus 4 is 0, so that leaves 12. And on the right side, 6x minus 4x is 2x. So we end up with 2x minus 5 equals 12. Eliminate the constant from the left side. 2x minus 5 plus 5 is 0 equals 17. So that means that we have 2x equals 17. Divide by the coefficient. X is equal to 8.5. On the second equation, we don't have any fractions, so we can just simplify by multiplying 3 across the parentheses or distributing it. So this one, negative 18, is equal to multiply 3 times x and multiply 3 times 2, and you get 3x plus 6. Normally, we move our variable to the left side, but I'm going to use my properties of equality and my property of reflection, the reflective property, to just change the order. 3x plus 6 is equal to negative 18. Eliminate that constant from the left side, and you get 3x plus 0 equals negative 24. Well, 3x plus 0 just leaves 3x equal to negative 24. And when you divide both sides by 3, you get x is equal to negative 8. We'll just write that right there. Let's go on to number 3. X minus 24 divided by negative 4 equals 7. Get rid of that fraction. Multiply both sides by negative 4, or multiply everything in the equation by negative 4. On the left side, negative 4 divided by negative 4 leaves 1. So it leaves x minus 24 equals, and negative 4 times 7 is negative 28. Eliminate the constant from the left side. Negative 24 plus 24 leaves x plus 0. So it went away. And on the right side, since you do the same thing to both sides, you end up with negative 4, or x is equal to negative 4. Let's go on to number 4. 2 times the quantity x minus 4 is equal to 6. Distribute the 2 across each term, and you get 2x minus 2 times 4 is 8 equals 6. Eliminate the constant from the left side. To eliminate a minus 8, I have to add 8 to make it be 0. So I end up with 2x plus 0 is equal to 14. So that means that 2x is equal to 14. And when I divide both sides by 2, I get x is equal to 7. Moving on to number 5. 40 times the quantity x minus 2 is equal to 24x minus 24. Distribute. 40 times x is 40x, and 40 times negative 2 is negative 80, equals 24x minus 24. Now, eliminate the variable from the right side. 40 minus 24 is 16x. Bring everything else along because you got to keep it with it. So you end up with 16x minus 80 equals negative 24. Eliminate the constant from the right side. Since I'm subtracting 80, I have to add 80 to both sides. That gives me 16x equals, because negative 80 plus 80 goes to 0, and negative 24 plus 80 is negative 104. Whoops. Well, let me see if I can learn how to write on your smartboard. 16x equals negative 104. So now I have to divide by the coefficient. And I get 6.5. So x is equal to 6.5. Number 6, our last solving equation example, has a fraction. Do you see that 3? Multiply everything in the equation by 3, that denominator, and it will make the fraction go away. 3 times 9 is 27x, and 3 times 2 is 6. So on the left side, we get 27x plus 6 equals. On the right side, the 3's divide out. 3 divided by 3 is 1. And so you're left with 7 times x minus 6. So that gives us 27x plus 6. Now let's distribute across the parentheses. And we get 7 times x is 7x. And 7 times 6 leaves us minus 42. Eliminate the variable from the right side. Subtract 7x. It goes to 0. And on the left, you're ending with 20x plus 6 equals negative 42. Eliminate the constant from the left side. I'm going to bring it up here to the top. 20x plus 6 equals negative 42. I'm going to subtract 6 to eliminate the constant. I get 20x plus 0 equals negative 48 when I divide both sides by 20. I get negative 2.4. All right, so that takes care of the first part, A. Now let's go on to part B. Solving equations with one solution, no solution, or infinitely many solutions. Again, the exemplar tells us that we have to first distribute before we can do anything else because we have to simplify. That's always our first step. What can you do to simplify? When I simplify, I get 18m minus 18 is equal to 18m minus 18. Well, those are the same thing. Do you see? The left side is exactly like the right side. When I see that a number is equal to itself, or they're both the same, that tells me that there are infinitely many solutions. I don't have to finish solving it all the way to the end, but if I did, and I moved my variable from the right side and subtracted 18m, it would go to 0. And 0 minus 18 is negative 18. And so even if I did the next step, I would end up with negative 18 equals negative 18, a number that's equal to itself. And so because it does not have a variable, when you get a number equal to itself, it means infinite solutions. Of course, if I'd gotten two numbers that were not the same, that would have told me that there were no solutions to this equation. And if I had gotten an x that had not eliminated, then of course I would have known that that was one solution. That's the regular ones we always do. So we want to use those strategies to help us solve these problems. The first one has a lot of stuff to simplify. We've got to distribute across those parentheses. So let's do that first. Negative 6 times negative c is 6c. Negative 6 times negative 2 is plus 12. Plus 11c equals negative 16 plus 15c. Well, 11c and 6c are 17c. You see these two right here? Those are called like terms. Put them together. Plus 12 equals negative 16 plus 15c. Now when I get here, I don't have to solve the rest because I can tell that on the right I've got 15 c's and on the left I have 17. So I'm going to have some c's left over. If I subtract 15 from both sides, I'll have 2 c's left. So this one has a solution because the c's are still in there, the variable is still there. So I'm going to stop at this point because I see my pattern, and I'm going to say that this has one solution. Number 2, distribute to simplify. Negative 5 times negative x is 5x. Negative 5 times minus 2, or negative 2, is positive 10 equals 10 plus 5k. Oh, that's not a k, that's an x. Sorry guys, typo. They have to be the same variable. So 5x plus 10 is equal to 10 plus 5x. Well, if we use our reflexive property, doesn't that mean that 5x plus 10 is equal to 5x plus 10? They're the same. So when they're the same, and you can see that they're going to be the same number, because if x were 1, they'd both be 15. If x were 2, they'd both be 20, and so on. Because they would be the same and we saw the pattern, we're going to stop and we're going to think, Okay, when the numbers are equal to themselves, when a number is equal to itself, when they're the same, I have infinitely many solutions. That's just like the one up at the top. So I'm just going to write infinitely many. And let's go on to number 3. 2 times 3x and 2 times 7 have to be done first. So 2 times 3x is 6x, plus 2 times 7 is 14, plus 2 equals 6x plus 9. Put your numbers together, they're like terms. 6x plus 16 equals 6x plus 9. I don't need to go any further. I see a pattern. Do you see it? The 6x and the 6x on both sides, when you subtract, will make 6x's go away to 0. And I'll be left with 16 equals 9. But that's not true. And so when I get a statement or a pattern that shows me that the statement is not going to be true, that it's just false, then I turn around and I say that there is no solution for this equation. Because it's going to give me fake ones, you know, like they're pretending to be answers, but they're not. Number 4. We don't have any parentheses, but we do have to combine like terms because we have a 5x and a 10x, and we've got these numbers 8 and 1. So let's make this simplified. 8 minus 15x equals 5x plus 10x is 15x, and 8 plus 1 is 9. Again, you see how this minus 15, oh, don't let it fool you. Subtract 15x from both sides. It almost fooled me, and I already solved these. Make this go to 0, and you get 8 minus 30x equals 9. And the next step that we have to do is eliminate the constant from the left side. When we eliminate the constant from the left side, we end up with negative 30x equals 1. And so when we divide by negative 30, we get one solution. We don't have to keep going, though. We can tell it's a solution. So we're going to stop there and get rid of all of this stuff because this is a one solution answer. One solution. Number 5. 5 times negative 5x, 5 times 1, so that we can simplify. 5 times negative 5x is negative 25x. 5 times 1 is 5 equals negative 20x. Do you see how the x's are two different numbers? So if I added 20, I'd still have some x's left over. So again, this is one solution because we didn't eliminate the variable. Number 6. We have some parentheses, so let's distribute on both sides. 2 times x is 2x, and 2 times negative 4 is negative 8, equals 3 times x is 3x, 3 times 7 is plus 21. Eliminate your variable from the right side. Subtract 3x from both sides. That leaves negative 1x, or the opposite of x, minus 8 equals 21. Did x go away? I didn't have to do that. Look, I could have looked. I didn't even look for the pattern I tell you to look for. 3x's and 2x's are not the same, so an x will be left over. So this is also a one solution. I don't even have to worry about whether it's a decimal fraction. It doesn't matter. I just want to know the number of solutions. So I look for that pattern. Now, we have one more set to do. Part C, functions. The exemplar I gave you is an equation, and I asked you to find missing values. But let's talk about functions for just a second. When we have a function, it has to have unique values. There has to be one input for each output. If the input repeats and shares more than one output, or if the outputs share one input, it's not a function. So this is that function, not a function rule that we started with. Look at this table. I'm missing a value right here and here, and I need to find those numbers. Well, I can do that. I have an equation, y equals 3x minus 2. So to find this missing input right here, all I have to do is use negative 2 as my output, or my y. So I'm going to replace y with negative 2, and then I'm going to solve the equation. I'm going to eliminate the constant so that I have 2 is equal to 3x. I don't know why I just did that. I'm not even going to redo this video though because it's really late and I'm tired. Let me start over. When I do this, I'm going to eliminate the variable, but I'm going to do this. I'm going to change places because it doesn't matter which side they're on with an equal sign. I'm going to replace y with negative 2, and that gives me 3x minus 2 equals negative 2. So I'm going to add 2 to both sides, and I get 3x equals 0, or x is equal to 0. And so for this first missing value, we get 0. For the second missing value, I have the input, but I don't know the output. So I'm going to write down the equation just like I saw it, but instead of x, I'm going to replace it with 6, the input value. 3 times 6 is 18, minus 2 means that this missing value is 16. And so if you're given a table and asked to fill in missing values, that's really easy. You just substitute. So now let's look at this. Is this really a function? How do I know if it's really a function? Well, if you go back to your notes, you can see that we only look at the inputs. And we look to see if they're all the same, or if any of them are the same, or are they all different. Because to be a function, every input has to be unique. It has to be different. -3, 0, 2, 6. All of our input values are unique. So that is a function. And we found the missing values. For the timed practice, we had 6 problems, and we had to do different things for some of them. So let's take a look at number 1. It says function or not a function. Well, take a look at the inputs. Your domain or your input values or your x's, whatever you want to call them, are 0, 2, 3, 7. Since every one of those numbers is a different number, this is a function. Number 2, ask the same question. Is it a function or not a function? Look at your input values. What do you see? Uh-oh. I see that we have -2 twice. Can't have that. So this one is not a function because x was not unique. Number 3, function or not a function? Look at your inputs. You should always box them so you can see them. 4, 1, 0, 4. No, that won't work because 4 is an input twice, and it can only be an input one time. So this one is also not a function. Number 4 has got this graph. I haven't seen graphs like this. What the heck is this? What is the output when the input is 1? Well, I don't know, but I'm just going to trace over to 1, and then I'm going to go up to my function, and that number that my function lands on looks like it might be 6. So I'm going to say the answer is 6. Number 5 says the same thing. What is the output when the input is 5? Well, all of the inputs are always on the x-axis. So you could say, because there's an x, so that's x or input or domain, but we want input. So our input is 5, so let's go over here to the number 5 on the graph. What is the output? Trace it up to your line. Looks like it's 8. Number 6, is this a function? I don't like all those ordered pairs and commas. They get on my nerves. So I'm going to create a table. And I'm going to put my inputs. And I'm going to put my outputs because I don't like leaving the right side of my table blank. But I don't need them for this part. Box your inputs to tell if it's a function or not. 2, 4, 3, 6, 2. Uh-oh. I see more than one 2. So this is not a function. And that's it, guys, other than your reflection, which you get in class at the end. I hope this helps you, and have a good night.